There's a lot of protein wastes that we produce right now as a society that are not really used. In 2008, it was estimated there's about 1 billion tons of manure. That is a lot of manure that is not fully utilized. A good portion of that is left to aerobically compost, and that produces a lot of nitrous oxide and a lot of methane emissions, which are greenhouse gases that are 325 times more potent than CO2, respectively. Our laboratory works on applying biology and biological principles to solve engineering problems. Anything that comes from a non-renewable source, we're looking to develop a renewable way to make it. We're looking at using all sorts of different waste feedstocks, anything such as agricultural waste like manure, municipal waste like sewage, plant matter, and we work with a variety of different bacteria, a variety of different organisms to get them to produce different compounds. And what we're focused on right now is sort of advanced biofuels. They have more favorable properties as a fuel than ethanol. Ethanol is not an ideal biofuel. It doesn't have the exact same burning properties as any of the other liquid transportation fuels that we use. It is not quite as energy dense, and it is corrosive to metal and to the fuel infrastructure we already have in place. We try to produce branched chain alcohols that are a little larger, and they're therefore more energy dense, and they burn more like real gasoline. They're therefore compatible with current fuel infrastructure. You can drop it right into your car. You don't need any modification. Bacteria have evolved over billions and billions of years to find protein in the environment and then use that to grow. However, we don't want them to do that. We try to engineer the metabolism of bacteria so that instead of just growing on this protein, they will now take a good portion of it and use it to produce products for us. So Bacillus subtilis is a soil organism. It's recognized as safe by the FDA, which is a good step for developing this process for industrial deployment. We've engineered Bacillus subtilis to produce alcohol biofuels and ammonia. We don't have the highest yield. So what we're doing right now is trying to further study the metabolism of this organism, see how we can alter it, adjust it. Once we improve our yield of biofuels, then we can start looking at, can we scale production of this up? To me, it's important that we come up with technology for renewable energy. In an academic setting, we have a little more freedom to investigate basic science, generate new theories, new hypotheses that you might not be able to do in a corporate setting. And because of this, we can be sort of an engine for generating new ideas. And right now we're working with guidance from a company in industry as well as US Department of Energy to make something economically solvent or viable on an industrial scale.
Want to learn more about climate change? Check out our other video and make sure to click that subscribe button.